Hi all, welcome to the review for Unit 11, Coordinate Geometry. Please make sure you're done with lessons 1 through 8 before you start with this review. Also, try to upload all your independent practices onto the Canvas website if you have not done so far. Please print this packet also, and if you do not have access to a printer, just copy the questions on a separate sheet in your notes, and also find a ruler if you can to sketch out all the graphs, because it will be very easy for you that way. Okay, so let's get started with the first question. It says triangle ABC has vertices A, B and C. So the coordinates are given. If you've noticed, the coordinate for A is x comma 3. So the first coordinate is always your x coordinate, and the second coordinate is your y, which is 3. So if you think about it, if my y is 3, y equals 3 is this line, right? I'm just going to sketch it here. This is the y-axis, y equals 3 will be this line, right? So my point will be somewhere on this line. I don't know my x coordinate, but since my y is 3, it's going to be on this line. So that kind of approximates you or gives you an idea of where your point would be. Now it says determine and state a value of x. So we want to find a x that would make this triangle ABC a right triangle. So again, right triangle means the lines are going to be perpendicular and the slopes are, how do I find perpendicular lines? Negative reciprocal slopes, right? So justify why ABC is a right triangle. Justify means show work. That's what justification means, show work. So this word justify means show work, okay? So I already have the T-chart set up with my sides of the triangle. So I want to find the slopes because we are trying to prove that the lines are perpendicular so that the triangle is a right triangle. So what's the slope of BC? Again, read your line from left to right, right? Or trace it. It is going down. So the slope is going to be negative. And how much? It's rise over run, right? So it's down 3 over 2. So it's negative 3 over 2. Any line that's perpendicular to this line will have what? A slope which is a negative reciprocal. So what's negative reciprocal of this? Of anything opposite of negative is positive, and you flip the fraction, so it's going to be 2 over 3. So basically from B, I am going to start plotting this point. I'm going to go up 2 over 3. So up 2 over 3. Would that be my point A? No, because I know it is going to be on the green line. So I'm going to keep going till I hit the green line. So up 2 over 3. And look, I am on my green line. This point is 3 comma 3, right? Because my y coordinate, which I always know was 3, my x is this point. So this is my point A. I'm just going to use this marker and freehand, and this is my point A. So what were the coordinates of your A? It is 3 comma 3. So let's fill that in. It's 3 comma 3. Okay, so now triangle DAN is graphed on the set of axes. The vertices of triangle DAN have coordinates. They're given to you, which are already plotted. It says determine the area of triangle DAN. So we basically want to determine the area of this shaded region, like if I was to shade this or this triangle, right? How do I find that? Okay, since these are not straight lines, like what's the formula for the area of a triangle? It's base times height. If you look at the base, it's not a straight line, so can't really help with that. So if we draw a rectangle around it, if you think about this, I'm just going to highlight it with the green and see, isn't this a rectangle? If I find the area of this rectangle in green and subtract the sum of these 3 triangles that I built around it, triangles 1, 2, and 3, I will be left with what? Area of the given triangle. So I already filled in the formulas. So area of a rectangle is length times width. So what's my length? My length is 11 up 11 times 12, right? Which is 120. 32 square units. Okay, so now similarly, I'm going to find the area of each triangle. I drew the triangles around. What is this length? This length is 11 and this is 3. So it's going to be 1/2 11 times 3. So which is 33 over 2, which is 16.5. The next one is, what is my length across? It is 9 and this is 7. You can just count the boxes. All I'm doing is counting the boxes. So let's put it in 1/2 times 9 times 7, which is 63 over 2, which is 31.5. And the last one is 1/2. What is this length? This length is 12 and this is 4. All right, so it's 1/2 times base is 12 times 4, which is 24, right? 48 over 2, which is 24 square units. So you have your 3 triangles. If I add these up, I get what? 16.5. Hold on. So it's basically, if I add these up, I get what? 16.5 plus 31.5 plus 24 is 72. So that's 72. So what do we know? How do we find the area of the triangle? Let's write it down. Area of triangle, DAN, is equal to area of rectangle minus 3 triangles, right? So area of rectangle was 132 minus 72 is 60 units square. Okay, so now let's try the next question. It tells me that quadrilateral ABCD has vertices, and I already plotted them. And now it's asking me to prove that the quadrilateral is a parallelogram. What do you know about the parallelogram? How do you prove if any quadrilateral is a parallelogram? If you prove that both pair of opposite sides are parallel. If they're parallel means what? They will have what kind of slopes? So let's think. Same slopes, right? So let's find out the slopes of all these different sides. So the slope of AB is, first of all, look at the line. It's going up. So rise over run. So what's my rise? My rise is 5 and my run is 4. 5 over 4. Slope of BC. First of all, my line is going down, so it's going to be negative, and it is what? BC is, it's going 4 down 4 over 5, and then CD is again a positive line. It is 5 over 4, rise over run. I'm literally counting the boxes, right? And the last one is DA or AD. It's again line going down, right? If anyone is confused with that, we talked about it in our previous lessons. Look at this. If I trace my line from left to right, I'm going down, right? So that's why I said it's going down. It is going to be a negative slope, and it is what? 4 over 5. So what do I know? Look at these slopes. I'm just going to take this. Look at these. They have same slopes, and these two have same slopes, right? So what can I say? Same slopes, right? Let's write that down. Same slopes for both of them. So what can I say? ABCD is a parallelogram. Literally the same definition that we were trying to prove, used to prove that they are parallel. ABCD is a parallelogram because both pairs, you have to prove both pairs, not one pair, both pairs of opposite sides are parallel, right? Okay, So the next one is prove that the quadrilateral ABCD is a rectangle. Again, go back to your notes if you don't remember. How do you prove anything is a rectangle? You want to prove all angles are 90 degrees. Like these angles are 90 degrees. Okay, whenever we talk about 90 degrees, what are we talking about? These means these are perpendicular lines and means their slopes are going to be negative reciprocals. So look at this. I'm just going to highlight them actually in a different color, in purple maybe. Look at this. This is 5 over 4 and this is negative 4 over 5. So adjacent lines are what? Perpendicular because their slopes are negative reciprocals of each other. So let's write it down. ABCD. So you didn't even have to do any work for it. It was already done for you in the previous question. ABCD is a rectangle. Again, you had to know the definitions, because if you did not know how to prove it, then it was all in vain, because all 4 angles are right angles. What told us 4 angles are right angles? Because what did we do? How did we use the slope to manipulate that? Because negative reciprocal slopes, what happens if you have negative? Sure. Perpendicular. You have to write that, please. Perpendicular. I've spelled it wrong. Perpendicular lines which form right angles, right? So if you look at any 2 pairs of adjacent sides, their slopes of negative are negative reciprocals. So that is it. So it was more of writing in this question than actually doing the work. The work was pretty basic, right? With all these coordinate geometry proofs, you're either doing lengths or you're doing slopes, and you're just interpreting those. So keep doing that. Okay. Again, know your vocab. It says 2 lines have the same y-intercept. Think about y equals mx plus b. Your b is your y-intercept. Are perpendicular means what? That the slopes are negative reciprocals, right? Perpendicular lines, negative reciprocal slopes. If the equation of one of these lines is this, determine the equation of the second line. So we know the equation of the first line is this. First of all, it's not in standard form. So let's write it in standard form. So I'm going to rewrite the equation. You want y by itself, so I'm going to divide each by 5. So I'm getting what? 3/5 x minus 2, right? That's my m and that's my b, right? So if this was my m and you know that the other line is perpendicular, so that my new m would be what? Flip it and negate it. So 5 over 3. My new m will be, I'm going to call this m1 and this I will be m2, equation of the second line, right? And it has the same b. So the b is what? Negative 2, because it said same y-intercept. So now, once we know this, right, and this, we can write down our equation. So our equation is y equals negative 5 over 3 x minus 2. So that is the equation of the second line with the same y-intercept, negative 2, but they are perpendicular. Okay, so let's start number 5. It says given points A and B. I've already plotted the points. It's asking us, it has 3 parts. This question has 3 parts. So let's do one at a time. It says determine and state the slope of the segment. We know the slope is what letter? M, right? Again, whenever you see that thing, you need to know of the segment. Again, if I was to trace this line, AB, or segment AB, from left to right, you always read your graphs left to right, okay? And so while I was tracing it, what was it? It was going down. I know my slope is rise over run. It's going down, so it's gonna be a negative slope. And how much down am I going? I'm going down 5 over 10. Literally count the boxes and always have your final answers as simplified forms. So it is negative 1 over 2 or negative half. Okay, so this B part is a little tricky. I just want you to like pay a little attention to it. Copy the notes first and then watch the video, or watch the video and then copy the notes. Don't try to do two things at the same time. So you might want to pay full attention to it, more attention to it. Okay. So now here it says determine and state the coordinates of the midpoint of segment AB. So now, first of all, whenever we talk about coordinates means we're going to write them as X and Y letters, right, in parentheses. And the midpoint, what does midpoint mean to you? Midpoint means something that divides into two equal halves. So where is the midpoint? I can either eyeball it, not necessarily it will be accurate. What do? You first find the slope. So the slope we already found, the original one, not the simplified one. It was what? My slope was -5/10. Midpoint means what? We're dividing it into what? Two halves, right? Equal halves, like 1:1. So I'm going to divide my numerator and denominator by 2. That's what you do. So you get 2.5 if you divide that, and this would be 5, right? Now, this is not my coordinate. This is just going to tell you how much from point A you're going to go down and over. So I'm going to put those points. Look, I'm going to go down. 2.5 means 1, 2, and 2.5 is like halfway, right? This is 2.5. And then 5 over 1, 2, 3, 4, 5. Your quick check would be you'll always end up on the line. If you do not end up on the line, means you made a mistake. So that's your midpoint. I'm going to label it M. It really doesn't say, but I'm just going to label it so that you know for your reference. So what are these coordinates? This is 1 comma. So the midpoint coordinates, that's 1 comma 4.5, right? Because we went halfway down. So this was something that students usually get confused with. So just if you don't understand it, look over it again and try to do multiple questions, because number 6 is very similar to that. Okay, let's finish up C, and then we will get to our next thing. It says determine and state the length of AB. Okay, so anytime you're working with diagonal segments, if they're horizontal, we've talked in the past lessons also, if they're horizontal or vertical, you literally count the boxes. But if they're diagonal lengths, you can actually build a triangle, a right triangle around it. So I'm going to build a right triangle around either the top of the line or the bottom of the line, right? So either the top of the line segment or the bottom of the line segment. So what is this? This length, it becomes a right triangle. This length is 5. This is 10. You want to find this length, right? You want to find this. So what do? It's a right triangle. You know your Pythagorean theorem. Anytime you're working with the right triangle, you need to and you want to find a missing side across from 90 is your C. So it's going to be, write your Pythagorean theorem. I like to write down my formulas first because you end up making less mistakes. So my A is what? 5 square plus 10 square. We don't know our C, right? It's across equals C square. It's not telling you to simplify it. So you get what? 125 equals C square, and C is equal to square root of 125, right? Or I can say AB, segment AB is square root of 125. It's not telling me to simplify around it, so I'm going to leave my answer. Okay, so let's get started with number 6. I already have given some notes here again. So it's very similar to number 5, but a little bit more work and a little bit more understanding here. So it says state the coordinates of the point on the directed segment. Whenever it says the word directed, it means the direction does matter. Okay, so it's going from A to B. I already have the points, but I'm going to put a little arrow at B because it's going in this direction. It said direct segments from A to B. So it's starting at A and is going to B and in that direction. That divides it into a ratio of 3:2. So basically, my whole idea is to find a coordinate that divides the segment AB into a ratio of 3:2. Okay, ratios are basically fractions, right? So basically, total of how many parts do you have? 3 plus 2 is 5. So I wrote the steps here in this box, so follow them. So what does it say? It says find the slope of the segment. So let's find the slope again. My slope here is going to be negative because it's going down. If you trace the line, and it is going down 10 over 5, right? So we have that. Now it's saying don't simplify it, leave it like that. Add the ratio. We already added the ratio, and the ratio is what? 5. That's my ratio. So now you take that ratio and divide the slope by the sum of the ratio. So which was what? Divided by 5. What do you get? We get -2. So we're going to go down 2 over 1. So this is the number that we're going to use to divide our segment into 3:5 ratio. So we're going to go in, or 5 equal parts, right? So I'm going to go down 2 over 1. Down. I'm going to start at A, okay, not at B. Please make sure. So start at A because it's a direct descent. Down 2 over 1. That's my first part. Down 2 over 1. And each time you divide that, your quick check is that you will end up on the line segment down 2 over 1. Down to, you kind of have figured it out where that point is. Down 2 over 1. Look, how many parts do we have? If I was to divide it into, this is my 1 part, 2, 3, 4, 5. So I divided the segment into 5 equal parts. I need it to be divided into 3, which would be 3:2. Do you agree? Those parts are 3 and that's 2. So my point is this. I'm going to put it in red. And what is that point? 2, 2. So your final answer is 2, 2. Okay? Okay, let's get started with number 7. It says in the coordinate plane, the vertices of triangle RST are given. I already plotted those points. Now, what is the question? There are 3 parts to it. So what does it say? It says prove that RST is a right triangle. This is very similar to question number 1. So anytime you want to prove something's a right triangle, you think of what? Perpendicular lines. Means if I can prove any 2 lines are perpendicular, means their slopes are what? Negative reciprocals. I will be able to say that it is a right angle. So let's start with RS. What is the slope of RS? Okay, so I want you to try it. If you look at RS, if you trace it, it is positive, so it's going up 3 over 5, right? Rise over run. So it's 3 over 5. Okay, so that's my slope. So what's the slope of TS? Here you get it, the line's going down, so it's going to be negative, so it's -10 over 6. Okay, now you'll be like, oh my god, these slopes are not even negative reciprocals. This is because this is not simplified. Simplify it, which is same as -5 over 3. Now these two are what? Negative reciprocal slopes. So let's write that down. Therefore, oh, I spelled, therefore means what? Can I say RS is perpendicular to ST? That's like a big thing, right? And that's why we can say that this is a right triangle. So let's sum it up. So I'm going to write here, triangle RST is a right triangle because it has a right angle. Right? And then what do I write? Negative reciprocals. Okay, I'm writing more because as long as you write something about negative reciprocal slopes, reciprocal slopes of 90 degrees, you will be fine. Shows perpendicular lines which form right angles, right? Okay, so now at the next one, it says part B says state the coordinates of point B such that quadrilateral RSTP is a rectangle. Okay, this is a little tricky. So it says RSTP. We have RST. We don't even know P. We want to find P. You know what? The opposite sides of a rectangle are congruent, right? So, and what else? First of all, think about it. R, you're going from R to S. I'm just going to put the arrows. S to T. Your P will go here in this direction. It'll be somewhere around here. So if you were to make an educated guess, you could. Or what's the slope of ST? The slope of ST is, what was the simple one? Negative 5/3, right? You know the adjacent side TP would be perpendicular to it. So what would be the slope of this? 3/5. So you're basically going up 3/5. So I'm going to go 1, 2, 3/5. 1, 2, 3, 4, 5. Just going to erase this. And it's up 3, 1, 2, 3, 1, 2, 3, 4, 5. And that is where your point P is. I'm going to use a dotted line so that you see this is P, label it P. And what are the coordinates of that? Those coordinates are, you must write down the coordinates, 3, 7, right? So again, it goes back to memorizing the properties of rectangles, of the quadrilaterals that I think we did in lesson 5, and we kept doing it all along, right? Okay, part C. Now it says prove that quadrilateral RSTP is a rectangle. So what do we do here? If you want to prove something is a rectangle, what do you say? 90-degree angles, right? So if I can prove that it has 90-degree angles, means what? Their slopes of the adjacent sides are gonna be negative reciprocal. So let's find the slopes of all the sides. So let's start with TS. The slope of TS is what? Negative 5/3. The slope of SR is 3/5. The slope of TP is 3/5, right? If you simplify it, it is 6/10, but if you simplify it, sorry, TP is 3/5. I was thinking ST. And PR, just want to do a different color for each one. So PR is negative 5/3, right? Look at these slopes. I'm just going to compare them. This is negative 5/3. This is 3/5. They're all negative reciprocal slopes if you look at the adjacent sides. So again, we need to do the writing. RSTP, you must always write a conclusion is a must with coordinate geometry proofs. Otherwise, it's just finding slopes and lengths. Is a rectangle because all 4 angles, oh, I can't fit angles there. All 4 angles are right angles. Same thing what we wrote up above, negative. But the more you write, the better you get with the writing and know what to write. Negative reciprocal slopes show perpendicular lines which form right angles. Okay, so let's start with number 8. It says which type of triangle can be drawn using the points BAT. So okay, there are 3 points for BAT. I already sketched the triangle. It says justify your response. Even though it's a multiple choice question, if it says justify, means you must show your work. So I wrote the definitions of all what they mean: a scalene, isosceles, equilateral, equiangular, and right triangle. What are these triangles, right? So now let's figure it out. If we want to show that anything is congruent, if you want to show any of the first 3, scalene, isosceles, or equiangular, we need to find the lengths, right? So let's find the length of each side. Let's start with AB. So length of AB is what? It's a vertical line, so I can literally count the boxes and it is 10, right? Now AT, I am going to actually draw a right triangle around it because it's a diagonal line. right? We've been doing that for quite some time. This is what, 6, and this is 2. So AT would be what? 6 square plus 2 square equals C square. So if I simplify it, I get what? 40 equals C square. So C will be what? Square root of 40. Now I'm left with BT. So again, it's a diagonal line. I can actually I can draw a triangle around it, which I usually have been drawing it earlier, but I forgot to do that. So what are these sides, right? So this is 6 and this is 8, right? So now let's do this. BT is 6 square plus 8 square equals C square. 100 equals C square. C is equal to square root of 100, which is what? 10. It's a perfect square. So you didn't have to leave it in radical form. So now just think about it. Look at the lengths of, did you notice something? The length of each, two of them is the same. So BT and AB are what? Congruent, right? So let's highlight them. AB is 10 and BT is also 10. So what can you say? Two sides are congruent. So it is an isosceles triangle. So it is choice 2, right? You can find the slopes also to determine if it is right triangle, but we don't need to at this point because we're already using lengths. We were able to determine that it is an isosceles triangle. So choice 2 was your answer. I would highly recommend, if you're having difficulties with any questions, go back, review, check your work, and that's what it is.